back, everybody. Today we're going to be talking more about complex numbers and complex roots. So let's just go ahead and jump right into the notes. So, real versus complex roots. A real root is going to be either rational or irrational. And so our real roots also include our square root numbers. So rational would be like 1, -3, 5 over 7, 0.33 repeating. Irrational would be like the square root of 3, 2 minus the square root of 5, stuff like that. But our complex roots are going to take the form of a plus bi, again, where this is real, and then this is our imaginary part. And so this b value could be an integer, it could be a rational number, it could be a irrational number, but it's a number and then with an I. And so the differences in the graphs, a real root is going to be like this. These would have 3 real roots. This would have 2 complex roots. Because it does not touch the x-axis. So a curve Okay, so we're going to talk mostly about complex numbers today, and then we'll talk a little bit more about these complex roots and what they mean as far as our graphs go in another section. So if we have the complex number -4 plus I and -4 minus I. So if we want to find the sum of these, so we want to add these together. So -4 plus I plus -4 minus I. So I kind of works a lot like X. We kind of treat it like a variable until we have I to a power. Then we want to simplify it like we did in 8.2.1. So these parentheses aren't doing anything. So this is just -4 plus I minus 4 minus I. So then we can combine our like terms. So -4 plus -4 would give us -8. But then these end up canceling. And so our answer is just -8. Now our product, this is going to be -4 plus I times -4 minus I. And so you can do your distributive property, or you can draw your box. And so then this would be -4 plus I, -4 minus I. And so then we distribute just like we would if it was an X. So -4 times -4 would give us a +16. -4 times I would give us a -4I. And then this would give us a positive 4i because the negative times the negative is positive, and then negative I squared. And so if you notice, we can combine like terms, but these two are going to cancel each other out. And so this is going to give us 16 and minus I squared. Now, if we remember from last section, I squared is actually -1. So this is 16 minus -1, or 16 plus 1, which would give us 17. Okay, so let's look at this next one, which is pretty similar. So the sum, this is going to be 3 minus 5i plus 3 plus 5i. So again, these parentheses aren't doing anything, so I'm going to drop them. So 3 minus 5i plus 3 plus 5i. And so again, when we go to combine like terms, 3 plus 3 would give us 6. But then negative 5i plus 5i, these are just going to cancel. So our answer is 6 for the sum. For the product, we're going to do a similar thing. So 3 minus 5i times 3 plus 5i. So I'm going to set up my box again. So this would give me a positive 9, negative 15i, 15i, and a negative 25i squared. So then again, when we combine like terms, these two are going to end up canceling each other out. And so then we would have 9 minus 25i squared. And again, remember that I squared is -1. This is a big thing that's going to continue to come up. So then this would be 9 minus 25 times -1. So 9 plus 25, which would give us 34. Okay, so this next one is similar, but it looks more complicated because of the square roots. Don't be intimidated by the square roots. So this would be 1 plus I root 3 plus 1 minus I root 3. And so then again, when we combine like terms, this will give us 2, and then positive I root 3 minus I root 3 are going to cancel. So our answer is just 2. This won't always happen, but in this case, that is what is going to happen. And then when we do the product, again, this means that we're taking 1 plus I root 3 times 1 minus I root 3. So I make a box. I'm going to make it a little bit bigger so I have enough room for everything. This would be 1 I root 3, 1 negative I root 3. So this will give me 1 times 1 is 1. This will give me negative I root 3. This will give me a positive I root 3. And then negative I times I would give me negative I squared. And then root 3 times root 3 would just be 3. And so again, negative I root 3 times plus I root 3 are going to cancel. So we just have 1 minus I squared times 3. Again, remembering that I squared is -1. So this would then be 1 minus -1 times 3. So 1 plus 3, which would be 4. We have one more that we're going to look at that's similar to this. So then this is going to be 1 plus I plus 1 minus I. So our sum would be 2. And then our product, you might be able to guess this, but let's work it out. This will be 1 plus I, 1 minus I. So then this would be 1 I, negative I, negative I squared. So then this would give us 1 minus I squared, which is 1 minus -1. That would be 2. Okay, so what complex number can you multiply 3 plus 2i by to get a real number? I ask the unanswering crowd. Blink, blink. This is just like teaching a real class with no answer coming to me. The answer would be 3 minus 2i. And so we'll talk a little bit about that in just a second, but these are what are called conjugates, and we'll take formal notes on that here in just a little bit. But if we notice on all of these, when we multiplied, in order to get a real number, each of these had opposite signs between them. The number in front had the same sign, so like -4 and -4, but all of them had opposite signs before the imaginary number, and so that's how we end up getting our real number when we multiply. Because if we have something like this, when we have two complex numbers, we're going to draw our box to multiply. This will be -4 plus 5i, -4 plus 3i. This would be a positive 16, -20i, -12i, and 15i squared. Again, remembering that I squared is -1. So then this would be 16 minus 20i minus 12i plus 15, and I'm going to go ahead and switch that I squared to be -1. Okay, so then we have some simplifying. So we can combine these two because these are like terms. And so then we would have 16 minus 32i minus 15. And so then this would be 1 minus 32i. And again, this 32i is just combining our like terms. And then we can take 16 minus 15 to get 1. Okay, so now for some notes about our complex numbers. So what complex number would you multiply a plus bi to get a real number? So that's what I was saying up here. This would be a minus bi. And again, it's because the sign in between them is changing. And so this is what are called conjugates. So find the conjugate of 5 plus 3i. So the conjugate would be negative 5 minus 3i. So again, the number in front is staying the same, but then the number in between is different. So we use conjugates when we are dividing by when we're dividing complex numbers. So we cannot have an imaginary number in our denominator. So when we have 2 plus I divided by 3 minus I, I'm just going to write it a little bit bigger. So 2 plus I divided by 3 minus I want to multiply by the conjugate of the denominator. So this conjugate is going to be 3 plus I. So then in order to get rid of the imaginary number, so in order to get a real number in our denominator, we're going to multiply by 3 plus I over 3 plus I. And so then my numerator, so you can do your box or do the distributive property. I'm going to do the distributive property at this time just to sort of save some room. And so this is going to be 6 plus 2i plus 3i plus I squared all over 9 plus 3i minus 3i minus I squared. And so again, we want to remember that I squared is negative 1. And so this is going to be 6 plus 5i minus 1 over 9. My 3i and negative 3i cancel, and then minus negative 1. So then this is going to be 5 plus 5i all over 9 minus negative 1 will give us 10. Now, the thing is, this can be simplified. We can divide everything by 5. So if I pull a 5 out here, this would be 1 plus I over 10. And so then our answer would be 1 plus I over 2. Now, at this point, I would accept this answer of 5 plus 5i over 10, but 1 plus I over 2 is the more simplified answer. Okay, so let's look at one more example. So we have 3 minus I divided by 1 plus 2i. So let's first write the conjugate. And so again, we're only concerned about getting the denominator to be a real number. So I want the conjugate of denominator is going to be 1 minus 2i. So with this, we have 3 minus I over 1 plus 2i. So I'm going to multiply by the conjugate of the denominator, 1 minus 2i over 1 minus 2i. So again, I'm going to do my distributive property. So this is going to be 3 minus 6i minus I plus 3i squared over 1 minus 2i plus 2i minus 4i squared. And so again, I squared is -1. So we're going to use that here. So then we get 3 minus 7i minus 3. 1, these two i's will cancel. So then plus 4. And so my 3's will end up canceling. So we get -7i over 5. And that is our answer. So with these complex roots, sometimes they're a little complicated, but a lot of the times it's really what we've already learned as far as multiplying, adding with variables, but we just have that added extra part that I squared is -1, and so we always want to simplify that. So please be sure to come to office hours if you have questions, or email me with anything that you have. I will see you later. Bye.